All right, guys, STAT1800, confidence intervals for two sample means. We're looking at the independent case right now. You'll hear me say this ad nauseum, but I think it's easier to learn new stuff if you can embed. I'll tell you what, this is driving me crazy. Let me see if I can get that a little clearer. All right, I think it's easier to learn new stuff if you embed it in something you already know. So if I have, just conducting a two sample test where H sub O is mu equal 18 and H sub 1. Can you tell yet? I just don't like that, but that's the way it is. Mu equal 18. And let's say the population's standard deviation is unknown. All right, so a confidence interval would be built around our sample mean x bar, and then we would add and subtract margin of error. And since the population standard deviation is unknown, I would have my t critical, and I would have my I would have my standard error. And guys, that's S sub x, even though it's the ugliest S sub x in the history of S sub x's. All right, that's better. So what we need to do is we need to think about this new problem where we have a null hypothesis, mu1 equal to mu2, which again is equivalent to H sub O mu1 minus mu2 equals 0. And H sub 1, mu1 not equal to mu2, which is equivalent to H sub 1, that the mean difference is something other than 0. So if you think about it, we've got a part right here, we've got a part right there, and we have a part right here. That part is the sample statistic. This part is our t critical for the t distribution, and this part is the standard error. Now, for these problems right here, what should go there? Well, what do we use to estimate mu1 minus mu2? Guys, that's the only thing it could be. X bar minus X bar 1 minus X bar 2. What do we put here? Well, as I told you in a previous video, this problem, I don't know if you noticed the Facebook thing pop up, but one of my buddies is getting ordained as a minister Sunday, and his sister let me know. So anyway, kind of proud of him. We're using t distribution, so also we would use t critical. Now, the hard part is this part right here. But really it isn't, right? If you watch the previous video, this is just the standard error, and we know that the standard error is just the square root of this pooled variance (1 over n1 plus 1 over n2 times the pooled variance). Now, I kept some calculations, right? We know that this part right here, that's x bar minus, x bar 1 minus x bar 2. We know that's negative 23.7. That has to go right there. Our t critical, let's say if we're doing, again, alpha equal 0.05, then we do a 95% confidence interval. 5 plus 95 is 100. That's the way it always works out. If this is 0.01, we do a 99. This is 0.10, we do a 90. Okay, again, just review from previous videos. So the t critical, let me thumb through my stuff here and find it. The t critical We did the t-critical approach was negative 2.10 and positive 2.10. Negative 2.10, positive 2.10. And then this stuff turned out to be 200.11665 times 0.2. Guys, remember that? Previous video, 200.11665. And this was 1/10 plus 1/10 is 2/10, which is 0.2. So this, all this stuff right here turned out to be 6.33. So we can very easily calculate our confidence interval. So our left bound will be negative 36.99. And the right bound, because second function entry, all we need to do is change that to a plus. Down where you can get some light. Negative 10.41. Now, sometimes this is written as negative 36.99 less than or equal to mu1 minus mu2 less than or equal to negative 10.41. Now, so what we're finding out here is the location does matter. In fact, when we examine x bar 1 minus x bar 2, because this is negative, that indicates that the first value is less than. So the difference in the mean sales per week of location, we can say that location number 1 is somewhere between 36.99 and 10.41 lower than location 2. Now, confidence intervals come in three forms, okay? Now, so confidence intervals, we can think about it. Now, again, let me back up here. When you think of confidence intervals, when you think of intervals just in general, intervals are part of that number line. And whatever value is to the left is always going to be less than the value to the right. You might be saying, well, duh, I knew that. Believe me, I've been teaching this stuff long enough. People don't always know that. The three forms of confidence intervals for differences of means is we have negative, negative, negative plus, or plus plus. An example of this would be something like negative 2 to negative 1. Again, the left number has to be smaller than the right number. An indication of this would be negative 2, positive 4. An example of this would be 2, 4. In all cases, the left number is smaller than the right number, but this interval takes on a form of negative, negative. This interval takes on a form of negative, positive, and this one takes on a form of positive, positive. Now, notice this one. This one contains 0. if the interval contains 0, we conclude that the difference in the means is equal to 0. This will always lead us to fail to reject the null hypothesis. Why? There's a 0.95 probability that this interval contains the difference in mu1 and mu2. Well, if that interval contains 0, then at a 0.95 probability, we conclude that the difference in the population means is equal to 0. This one, on the other hand, does not contain 0. And since both are a form of negative, this includes that our mu1 is less than mu2. This one, on the other hand, also does not contain 0. But because it's positive, that tells me that the first number, x bar 1, mu1, is bigger than mu2. So I conclude mu1 is greater than mu2. Guys, both of these will lead you to end up with a significant test and rejecting H sub O. Now, I'd like to conduct a test. And let's say population number 1, they always say never talk about politics. But I'm a good one to talk about it because I don't trust either party. So, I mean, I really have. I've completely lost faith in either one of these parties. And if you're just like all in on Democrats or you're all in on Republicans, good for you. Go for it. Be happy. I don't. I've lost faith in the whole thing. Okay, enough about politics. But let's say that someone wants to make a claim that they've come up with some scale, some measurement, and they want to test whether the average for the Democrats and average for the Republicans is the same. So the H sub O would be the mu for the Democrats is the same as the mu for the Republicans. And our H sub 1 would be that the measurement is different for the Democrats and the Republicans. Let's say I want to test at 0.05, which means that I would calculate a confidence interval. What do I conclude? Well, I go back to my handy dandy chart. This is a positive number, that's a positive number. Positive indicates that what? Doesn't contain 0. So we reject H sub O. And both these numbers are positive, which tells me that my first measurement is bigger than my second measurement. So the average for the Democrats is higher than the average for the Republicans. What does this indicate? Well, I have a format negative, positive, which contains 0. I fail to reject H sub O. I conclude that the mean for Democrats is the same as the mean Republicans. Guess somewhere in this interval right here, there's the value of 0. Another example. Negative 14.3 to negative 5.1. Guys, negative negative is the format. Right? Follow it down. What did we conclude? Reject H sub O. Tell you, I have to fight it. I had a graduate professor who always called it rejecting the hoe. Uh, and I know that's totally inappropriate, but it is what it is. And you have no idea how much when I'm teaching this, I say reject the hoe, but at the last second I say reject H sub O. So anyway, that's just kind of an inside narrative on what's going on in my mind. I think that's the first time I've let it slip. Okay, whatever. So since this is negative, this includes that the first number is smaller than the second. And again, that's the only way you get a negative number when you subtract something, right? 1 minus 8. The first number is smaller than the second if you get a negative. So Democrats, Republicans, that tells me that the mean for the Democrats is lower than the mean for the Republicans. All right, so guys, confidence intervals play a critical role in determining, when we have a test of hypothesis where we're testing equal to and we reject this, we can only conclude that the means aren't equal. But the confidence intervals based on the plus plus or the minus minus, if we do get significance, gives us an indication of which mean is actually larger and which is actually smaller. All right, gang. I think we've done enough damage here.